Hi everyone, today we will go to study the lesson 2 in my GTX NX tutorials about 3D excavation with retaining system. Okay, first of all, you open GTX NX. So we open the file. So you choose the starting file in tutorial. And then you open it. After loading, you can see this is the previous drawing, the setup drawing from tutorial. So you can turn off all the geometry. Go to the excavation and walling. So first you will create this area, become the excavation area. So you will go to extrude and select target object by selecting all. But here you need to change into face and then change from face to edge, and this is the edge. Just select all edges and then select the direction. You turn all the direction in here and select the direction, this direction, but you need to go down, so it should be a reverse direction, and then choose 2. You will go 2 meter and then go apply. So now the model is extrude 2 meters for each layer. Okay, so now turn on the ground area. Also extrude 80 meters for the ground area to cover the excavation area. Select direction, follow the Y direction and 80 meters and apply. So now the soil is covered for the excavation area. So now turn off the ground area. Now we cut the soil into different layers by using the cutting surface. Now the cutting surface is set up, and then we choose all. We choose the divine and then solid to cut the soil. Select target objects. We use the select all function to select all the geometry, and then we select tool face by the cutting surface, and then we apply. So now the soil is cut into 3 layers, and then we also need to use the bedding plane to cut for each 1 meter for the excavation area inside. So to do that, we can turn off this one, the bedding plane first, and then go to divine solid, select all, and then choose the select tool surface, and then turn off the geometry, and then turn all the surface, select all 3 surfaces, like applied, and then turn all back all the geometry. So now you can hide 3 soil layers to see the area inside. Now the soil is cut into each meter for the excavation area. So now we can change the transparent of this area, and then we can embed the soil, embed the plus beds. We change into the transparency is 2. So now you can see inside what happened inside. Okay, now we will imprint each of the plus bags into the different section for moving the same knot of the excavation area. So to do that, we go to imprint out to, and choose the excavation area. Select two objects. So we select for blood bags and then click apply. So now it's divided into layer by layer. Create more nodes, not only on the top and the bottom. Create more nodes along. Follow the layers of the excavation area. So now we will we will check the sharing surface, sharing face. So we go to the check duplicate, but now you can turn all this back and then check duplicate, select all and then apply. So now you can see this surface, and these surfaces don't have the same area with the soil around. So we want to make it have the same share surface. So to do that, you will go to Auto Connect, select all, and click apply. So GTX NX will help you to create the share surface. We check again and click apply. So now you can see the area, these areas have the same face. So that's why it shows as a duplicated. So that's what we expect to have in our model. Now we finished the geometry modeling. Now we will go to the mesh modeling. So the material and the model is embedded, is assigned before from the tutorials. So to save time, we will go to the next step without mention much about the material and property. Now we go to the mesh, and we need to mesh this soil area, but we should mesh in the detail first and then go to the overall mesh. So the overall surrounding soil is outside. It is not in detail as compared to the excavated area. So that's why we hide this first. Go to inside the excavated area. So we will control the signs in here first, and then we can excavate the outside area. We mesh in detail first. Remember it, and then we go to 3D mesh generation. The mesh size control is 1. Go to the hybrid mesh, select object all, and here advanced option, we select the interiors, choose the edges in here, blood bags edges, and then choose the wall blood bags and consider imprinting shape on face, and OK, and apply for this area. Now this area is control each 1 meter each. Then you will go to you open the geometry all, and then you will mesh for the surrounding area, soil area. Choose the 3 layers of soil, hybrid measure, control with 3 meter in mesh size. Go to apply. Okay. So now you will extract the surrounding area of the excavated into the sheet pile. Okay. Now you will turn off the surrounding soil. Selecting method, choose district, and then it. So now go to extract element. You can turn off all, and now this is the excavated area. You will extract element, go to extract element, selecting face. This is sheet piles, and see on the top, selecting these faces. So you have the surrounding faces here, and this is the sheet pile. Click apply. So you have been created the method for the sheet pile. Now we extract for walling. Turn off the sheet pile first. See on the side. Extract elements. Choose edges. This is the first one. Selecting walling. This is walling. Layer 1. Walling 1. Apply. So you can see the properties of it. Go to properties, 1D, walling. So layer 2, walling 2, blind, walling 3, applied, and walling 4, applied. We created mesh for different stages of the stress and anchor. In this study, we do 2 stages for stress and 2 stages for anchor. So first, we open the single stress. We close on the geometry first, and then turn on the single stress stage stress. So select this by 1D generate mesh. We select single stage stress, one size control, select stress, and this is the stress one. Apply, and open to stage stress. Select it. Still one. Stress properties. This is stress 2. Apply. So now we can slightly turn off this mesh for easier to see, and then turn on the third one. So this is the anchor. So we choose all, and then we choose anchor. This is anchor 1. This is anchor 3. We easier to know. This is the anchor 3 for layer 3 for construction stage 3. So apply. So we also like that for stage 4. So you can see here, or you can turn off anchor 3 first. Go here, select all, and anchor 4, and apply. So now the anchor is created. Okay, so close, turn on the mesh, and close on the geometry. Okay, now you have been created almost on the message. To see it clearly, you can turn off these three messages first, and then select this one and choose the transparent for it too, so you can see here is your model. We changed the soil properties in the mesh element parameters. We have changed properties here, but we need to choose the 3D change properties. So we select the basic and we can choose the message. So we select this message, and this is the buried layers outlined, and we need to select again for the basis this layer, select colluvium layer soil materials outlined, select back to basic, select layer 3, choose weathering soil, applied. So now the 3 layers of soil have been assigned correctly. Now select it back, change the name, rename it by buried soil layer, right? Buried soil. Select the second layer and change this into the colluvium, and the third one, this is the weathering soil. So we need to change the excavation area message for easier to control in the next stage of the defined construction stage. So this one we rename at the excavation 1. So this two we need to merge it together because this is the excavation 2. So merge selected method, yes, and select it, change the name as excavation 2. These two merge together, and this is excavation 3. These two merge together, become excavation 4. This one merge together, become excavation 5. And this is the excavation 6. But actually this is the soil below the excavation 5. So we have excavation 4, excavation 5, and this is excavation 6. Okay, and this is the blood bags. 2 blood bags. Okay, all the message is renamed. So for you to easily to control it, and now we will go to the static slope analysis. Define the state set. So now I will zoom the model down. So that's why you can see the construction state clearly. So we create the interface for retaining wall. So we will go to the create interface and plane, select the side view, and then now you can choose the from shell, because this is the shell element, and then you select all and select node, side view, choose the node at the bottom to create the grid link, to create a node for stability in analysis. Select the property parameters of the interface by GTX wizard. Interface wizard, so we have the reduction factor 0.67, and we use the default virtual thickness factor at 0.1 meter. OK, and create grid link applied. Okay, now you can go to the static slope analysis, create a constraint for your model, constraint, auto. So set the name as battery condition, and then define the gravity, follow the Z direction. This is -1 because it's a reverse direction with Z. So this is gravity, this is gravity, apply. Then one of the noted in this study is you have the blood bags here. So it will rotate, follow the Z direction, you can see. But we didn't expect that we want to prevent this rotation follow the RZ direction, because we want to prevent the degree of freedom errors due to the deformation of the blood bags rotate follow the for the RZ direction, because it is embedded blood bags. So during that time, it will have a like nearly don't have the rotation. Yes, so that's why we want to control this. To control this, you also go to constraint, but now you go to advanced tab and select the blood bags. So turn off all, choose the blood bags, message, select all, and then choose RZ. And here is rotation constraint. And then apply. Now blood bags is constrained their rotation. So in this lesson, the anchor 1, the anchor 3, and anchor 4 is have a pre-stress near to the sheet pile. So to define this, you go to the pre-stress slope statics analysis, load pre-stress with 200 kilonewton, and choose the embedded stress and stress. So select this is the pre-stress length, 200 mean the tension, and then here you can say is the pre-stress 3, pre-stress anchor 3, right? And then apply. So do that for the anchor 4. So pre-stress anchor 4 and apply it. Now we will go to the define stage. So we turn on the mesh and the analysis also. So we will turn on the battery condition, static load, and zoom down this. Go to the state set. Define the state set. So at the first stage name, so I will create the initial stress of the soil. So initial stage, clear displacement, select the soil that we need. The buried soil, column soil, excavation area, rigid link match between the soil and the excavated area in the first stage, and then select the weathering soil also. Then we create the boundary condition for the initial stage, a gravity condition, and after select all the activated data, we show data by the activated, the initial state created, we save it and create a new one. In this state, we install the retaining wall and we have the blood bag also. So blood bag and sheet pile. So we deactivate the data for rigid link match, but activate for the blend interface. And then self for the stage 2, create a new stage. In this new stage, we excavation 1 and we have the stress 1. So we excavation 1, we deactivated that we pick into the deactivated data for the excavated one mesh set, and then we install the stress 1 and walling 1. However, when we install the retaining wall and blood bags, you need to have the rotation constraint in here. So you back to the state 2 and rotation constraint, and self back for the state 2 and go back to the excavation 1, stress 1, and then you add new. Now excavation 2 and stress 2. So excavation 2 and stress 2, walling 2, self, new, excavation 3 and anchor 3. So you select excavation 3, anchor 3. So in anchor you have pre-stress anchor 3 also. So you have walling 3 and you have anchor 3, self, new, excavation 4 and anchor 4. So you excavation 4, walling 4, anchor 4, and pre-stress 4. Self, new, excavation 5, the activated data for excavation 5 match, self, and close. So all the stages is defined. So you logs, and now you create the analysis case, add, and this is 3D excavation. Select the construction stage, choose the construction stage defined, apply, and click solve. So after solving the model, you can have the results from the excavation 1 to excavation 5. So now you go to the excavation 5, we will discover the displacement of the soil at first. So you can see this is the total translation of the soil of your excavation area. So this is the area impact and displacement. Okay, now I will turn off the soil, barrier layer, weathering layer, and collegium area. So you can see here is the displacement of your retaining wall. So what if you see the deform in here? So this is the deform of your retaining wall. So you can see the form of your retaining wall here. Or you can see the TX translation. The displacement follow X direction, or displacement follow Y direction, or the sediment. So you can see, you can observe the beam elements. So you can see the axial force, or you can see the bending moment follow the Y direction of your walling, or you can see the stress element, you can see the axial force for your anchor. So you can see the shared element force or the YY direction, the shared element force, or the bending moment follow the Y direction. So you can see this is your wall, bending moment follow the Y direction. Or you can see the stress of the soil by opening this. So you can see here, or you can use undeformed to see. Okay. And here you can see you turn off the soil first. And here you can see the tension threshold point. This is the interface for your retaining wall and soil. So I turn off the sheet pile first. And tensions, relative displacement, or plastic tensions Y. But you need to turn on the plane strain and grid plane interface first. As you can see here, this is the interface between your soil and retaining wall during different excavation area at the stages. So you can see here is the first stage. The first stage, the interface will create in the first, the second stage, the third stage, the fourth stage, and the fifth stage. And you can compare that value with the total translation. Okay, this is the end for the 3D excavation of retaining system. Thank you for your listening.